second, third. I'll just do that many for now. We're going to start with x, right, for the first one. But here's the trick. Whatever this number is, I don't know, what do we call it? 17. A ridiculous number, but say it's multiples of 17. The next one is x plus whatever this is, 17. And then the next one after that would be x plus 2 17s, 34, etc. If that number was 4, it'd be x plus 4, x plus 8. So hopefully you get the idea of how to do consecutive multiples of a particular number. Now I hope you take all this down, and then I'm going to go on to number 11, and then I'll go back to number 7. All right, number 11. Find 3 consecutive integers such that, all right, so once you see the word such that, stop there and do the first 2 steps. How many integers? 3. First, oops, second, third. Now express them. Don't use the stuff after the such that to express them. You already know how to express these. These are what type of consecutive integers? Just consecutive integers. So we're talking about x, x plus 1, x plus 2. Don't start getting into the stuff after such that. That's only for the relate them, the equation. So when it says such that 6 times the first, all right, here's my equation. 6 times the first decreased by the third. Remember the parentheses when you subtract multiple things here. X plus 2, not just x. 6 times the first decreased by the third is 398. There is your setup, your equation. Now, since we have our equation here, we're going to go ahead and solve it. Please notice, the second one was never used down here in the equation. Just because they're up here doesn't mean they're all going to be used in your equation. All right, let's solve this. 6x minus x minus 2, 398. Distributed the negative. Then I'm going to combine like terms. 5x minus 2 equals 398. Then I'm going to add 2 to both sides. 5x equals 400. And I'm going to wrap it up by dividing by 5. X equals 80. Once you know what x is, plug it back in. 80, 81, 82. Remember, 80 plus 1 is 81. And don't put 81 in here. 80 is still x. All right. Back to number 7. Three consecutive even integers. Let's stop there. This is number 7. First, second, third. Also, make sure that if there is a label for a unit, that you include it with the answer. So far, we haven't had any, but there are a couple problems where there are. All right, consecutive even. X plus 2, x plus 4. Such that the sum of the second and third integers is 30 more than the first. The sum of the second and third, x plus 2 plus x plus 4. The sum of the second and third is 30 more than the first. 30 more than the first. Let's solve this quickly. So 2x plus 6 equals x plus 30. I'm going to subtract x from both sides. So x plus 6 equals 30. And then I'm going to subtract 6. X is 24. So if x is 24, x plus 2 is 26, 28. 24, 26, 28. 3 consecutive even integers. Oh, this is what I was going to say earlier, and I had forgotten. If this came out to 23 by some chance, that wouldn't be an even integer. If you got 23 here for x, that would not be an even integer. And if you did everything right and that was your answer, you'd say no solution. If you got a fraction or a decimal value, and you're talking about integers of any type, no solution. So I don't think any of them come out that way. In fact, no, none of them do, but just something to be aware of. All right, that was number 7. We're going to move on that worksheet to number 13 and then number 15, and that wraps it up for today. All right, number 13. This one's consecutive multiples. Find 3 consecutive multiples of 15. Stop reading. So we're talking about first, second, third. Consecutive multiples of 15. X plus 15, x plus 30. Now comes the such that twice their sum is 360. So twice their sum. Now you could either add these up and say 2 times that result, or you can write them all out. Twice their sum is 360. So you could have either written it that way, or you could have said 3x plus 45. And then distributed the 2. You could distribute the 2 here and then combine like terms. Any of those ways is fine. 6x plus plus 90 equals 360. So you can see that was simple to do. You could even here have divided both sides by 2 to get rid of this multiplication. And that kind of thinking can come up with other ones. Like if you have a fraction here, you could multiply by the reciprocal on both sides instead of distributing it first. But make sure there's nothing else there. If there was a plus here and then something else before the equal sign, you can't do that. All right, so now we're going to subtract 90. Oops, not 3, 6x equals, was it 270? Yes, that's correct. And then divide both sides by 6. You end up with x equaling 45. So 45, 60, 75, and you're all done number 13. Finally, we get to number 15. In number 15, it talks about a company's sales. And 15, we're talking about sales for 4 different months if you read it carefully. And the months are May, June, July, and August. Those are the months in which we are working. The company's sales for June increased 600 over its May. July were June sales and August, twice June sales in August, double July. Well, the one that's not talked about is May. June is May plus 600. July is twice June, so 2x plus 1200. I doubled both. You could write 2 parentheses x plus 600. And then August is double July, so 4x plus 2400. All right, there is the setup of the name it and express it. Next part is to solve, set up an equation. And it says the sales total was 20,200 for the 4 months. So the total of all these are the sales. If I add these up, x, 2x, and 4x, it's 8x. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Plus, if I add these up, it's 4,200 equals 2,200. 20,200. And then you just have to subtract the 4,200. 8x equals 16,000, and then divide by 8. X is 2,000. So now this is dollars. So dollars, 2,000. Dollars, 2,600. Let's see, this would be twice this. 5,200, and again dollars, twice that, 10,400, 10,400. And that's how you do it, folks. I hope this was clear for you. If not, let me know and I'll be happy to talk to you about it. Have a great day.